Hey, hello. So it's late Wednesday evening in the United States of America, but anyway, even though it's Wednesday, which seems to be a little Friday, we are having a pretty important topic of the webinar today. And this one is pretty important for anybody who is into the fintech and software development as well, because we are talking about the microservices and the ways of managing the distributed transactions as well. Being honest, I feel a little bit more nervous today than usually because this is technically the first webinar that we are running completely live without the pre-records as we did it before, but this is the format that we have decided to try. And for those who are watching our webinars for the first time, just a reminder that you are on the Insert FinTech Engineering channel, and for the upcoming 2 months, we are running an experiment of providing the webinars every single day for absolutely different topics related to the fintech. So you can see several of the webinars that we had during the last several days. Just open up our channel, go to the live tab, and you will see some pretty fancy things with absolutely different topics. Anyway, the one that we have today is extremely serious, and I believe it's going to be useful for anybody who's working with the transactions and with the payment systems as well, whether that's some sort of this third-party solution, or maybe this is something that you are providing as a functionality and as a part of your personal product. So first of all, before we get started, the agenda for today looks pretty fancy and is pretty interesting because we have a bunch of different topics we will try to cover and fit into the 30 minutes presentation. And as you can see, it has some yellowish tones today, which is not really about our branding, but anyway, this is just the way to keep people focused in the end of the hard working Wednesday. Anyway, microservice-based apps technically are the hyperloops of the fintech because being up and running on the rails and already increasing productivity, they provide some customer satisfaction as well. And that's the main idea of making the microservice-based app, is to keep the consistency, to run the productivity, and to provide some best practices. So no wonder that the use of the microservice architecture is on the rise today. And this microservice architecture we will be referring to as MSA in the next several minutes. And also, as fast and furious business setting demands some constant optimization, some sort of the new business-oriented services also allow market players to profit faster in a little bit easier way. So maintenance costs, time to market shrink, etc. That all takes your time, that all takes your money, that all takes your resources, and that can be painful for the new startup and for the new business, which is technically a pretty serious problem a role. So moreover, system parts become more and more atomic, and to help reduce costs for development support, this is the main approach that you should think of using. Like, try breaking down your system into the smaller parts, and you will get lucky and you will be happy with having less cost for this maintenance. But at the same time, as the pace speeds up, new challenges arise as well. For example, one of such complications related to MSC management is handling the distributed transactions. And that's the main topic we're going to be talking about today during the whole webinar. This aspect technically requires some special attention when building fintech products. And from our experience at Insert, we know that the MSA approach requires skilled teams who have successfully tackled various complications before. So this is not something you can handle from the very beginning, and if that's something you are facing for the first time. So today we will talk about these difficulties, how the distributed transactions can make you suffer, and at the same time, how to overcome these difficulties, how to bypass them, and what approaches are the best to be used in this case. One of those approaches, for example, is the Saga pattern that you might have heard a lot about, and the implementation strategies of which, along with the pros and cons, we technically have discussed in one of our articles. I will leave the description in the end of the webinar. Anyway, before we get started, just a reminder again that you're on the Insert FinTech channel. We are providing the FinTech services and development services for the financial companies for more than 30 years. And if you see that we can help you somehow with the development process, or maybe implementing some solution that can possibly help you earn more, feel free to contact us at www.insert.com. Otherwise, don't forget to hit like, subscribe, and join our channel because there's a bunch of really interesting things happening around all the time. Anyway, coming back to the topic. Why managing distributed transactions matters in fintech at all? Why do we need that? And what's the benefit? So to answer this question, I have used some insights from one of our colleagues, and he tried to explain the importance of distributed transactions management in fintech from the development perspective. Again, I'm the marketing specialist. I was a developer a long time ago, so it was the best approach to ask for somebody's expertise, which is new and up to date. So my colleague emphasized the need to pay special attention to the transactions and to transaction management aspect specifically when you are building such products. So here can be several, and to be exact, 4 different reasons to pay attention to. First of all, a fintech product operates on financial data that needs to be accurate and consistent in every single point of time. There is no possibility to break down this data. There is no possibility to break through some data chunks. Secondly, most fintech products have complex business flow and complex business rules, especially if some of phases include integration with, let's say, third-party solutions. So in this case, problems with file handling and overall system stability, for example, and consistency issues as well may arise and might be a pretty serious problem. So this is something you have to keep your attention at all the time. Next one, many ambitious fintech startups attempt to use cutting-edge technologies and architecture approaches, sometimes the new ones, even the ones that did not come out of beta yet. And if time to market is the chief priority, transaction management may be not in focus. So you are simply forgetting about that, and when you remember, it's too late. Next one, major and long-lived solutions were often developed using the monolithic architecture approach with traditional transaction management. And when they are being migrated to the microservices, it turns out that simple and familiar transaction management techniques are simply not applicable. And in the new architecture style, it's just impossible to follow all the rules and all the best practices. This seems to be a serious problem. It is not so simple to fix that later. So that's the thing that you have to pay your attention at as well. So technically, what is the challenge? Why are we talking about that at all? Why don't we talk about the management? Why don't we talk about marketing or something else? Why have we taken such a complicated topic? First things first, we're gonna start with the basics, because if you know what transactions are and what ACID and CAPE, for example, all about, you can simply skip the part of this webinar and you can join us in 10 or 15 minutes. But my goal is to explain every single aspect of what microservices are, how can we help in this case, and how the usage of microservice transactions can help you too. So let's try to start with the simple explanations. How do the transactions work? First of all, what is transaction at all? Technically, it is a sequence of information exchange and some low-level tasks that are needed to access and possibly modify the data, for example, updating the database. I know that sounds pretty complicated, and I'm going to try to simplify that. So just imagine that you need to perform some operation over your database. Let's say you need to extract some data and pass it over to your client. This part, when you are taking the chunk of data and you are passing that, is technically a transaction. This is the data transaction, some piece of information that you are trying to send from the data storage. It's not that simple to store such data, especially when we are talking about the financial services and financial solutions. Nobody likes losing their money. And if transaction is being compromised, this is the first key to lose money, to losing access to your wallets, etc. And that's a serious problem. So here are 4 magical letters that can help you avoid such a problem and do something pretty interesting just to make sure that that never happens. So these 4 letters are A, C, I, D. As you have already read from this slide, it's about atomicity, consistency, isolation, and durability. But what do these words mean except just a beautiful abbreviation? Atomicity, first of all, is about every transaction being completed with its execution or not to be completed at all. It is impossible to stop the transaction for a couple of seconds and then to proceed with it. the transaction either is being completed at a time or it's never completed and it has to run over again, which usually is impossible. So that's about atomicity. You cannot break your transaction into the smaller parts. It's unbreakable one, and it is impossible to divide it into the several separate pieces. Second thing, consistency. The result of transaction is a valid data. For example, an amount of money in an account just cannot be negative, and the transaction logic must check whether negative values will result. This is a pretty important thing because technically, if you have the inconsistency in your transaction operations, it is the easiest way to break down the logic of your financial service. For example, to try to transfer some minus value and to get the income on your account as a result. This is something that never has to happen. So when you're working on consistency, you need to make sure that you are extremely specific about what's going to happen and whether the transaction can happen at all or not. For example, you cannot return the decremented value on the bank account optionally, obviously, except if you're working with some maybe credit data, but that's mostly about the front end and not the value of your data transaction. Moving next, isolation. Concurrent transactions will not affect the outcome of other ones if they occurred in a sequence. So technically, transactions cannot affect one another if they happen concurrently, just because transactions are the independent pieces of data transfer. And usually this is also one of the foundations of security, of data security. So if your transactions are not isolated, you are not doing that correctly and you have to pay attention to it. And one last, it's quite simple one, but anyway, this is a pretty important aspect. One of the most important, I would say, is durability. So the updates resulting from transaction must remain persistent, even if the system fails or restarts. For example, you are trying to withdraw some money from the ATM machine. And at some point, you have made the request, ATM machine started working, and then the system fell down. Technically, after that, you expect that, well, okay, system fell down, your money remains at your account, everything's fine, you will get your card, possibly, maybe not, of course, and you will just go to the next ATM and you'll try to withdraw your money once again. But here, what's gonna happen if your transactions are not durable? In this case, you will not get your money, you will get your card back, but the balance on your card will be lower, it will decrement. That's because technically the transaction completed, it was persistent, and even though the system failed, transaction seemed to complete without providing the final result, without giving you money. So as long as such a problem persists, you will never be able to build a strong startup because you will always be losing money because of such things, and you'll be losing customers, you'll be losing customer satisfaction, etc. I know that sounds scary. I'm not trying to scare you in this case. I'm just trying to pay attention to the fact that these things are extremely important to pay attention at and to work with them. So once again, atomicity, consistency, isolation, and durability. 4 main whales of the strong financial service. Technically, ACID properties make a transaction reliable. So that's the easiest word to describe it. For instance, as a result of such a transaction, a money transfer will be complete and get to the right account, and the balance will not be negative as the result of such a transaction, just as an example that I have just talked about. Anyway, let's talk about the distributed transactions at all. What is that? How does it work? And why do we need these things? So ideally, the database would ensure consistency, availability, and partition resistance. But achieving them all is next to impossible in a distributed database system. So those are always some challenging parts that you might have hard to reach and you might be pretty problematic to achieve. There are no single node manages all the data that affects a transaction. And according to the CAP theorem, which we're going to talk about a little bit later, in a distributed system, it is possible to ensure only 2 of 3 possibles existing. You can never get all 3 properties, such as consistency, availability, and partition resistance at a time. It's just impossible. So the database can provide ACAD transactions only if it chooses consistency over availability and not the other way around. And here's a pretty beautiful demonstration of how this works and why is it so. So technically, from this triangle on the right side, you can pick only 2 out of 3. You can pick consistency, availability, or partition resistance, and you always have to throw away one of those. On the left side, there is a pretty simple alternative. It's about cheap, good, and fast. It is impossible to have 3 of those at the same time. And technically talking about being system being available, system being consistent, and system being fast, it is approximately the same for the fintech. So you always have to throw away one thing out of 3. And what it's going to be and how your system going to look like, that depends on you, on your business goals, and on how your business operates at the moment. But there is always something to choose from. Finally, if a transaction is unreliable and takes too much time to commit, it can seriously spoil user experience and negatively affect overall system bandwidth overall. So we will discuss when to use the distributed transactions and why it might get better to do that without them sometimes. Even though today we're talking about the transaction distribution, about speeding up the processes, about making a better customer satisfaction, there is still such situations when you just might not need using such a type of transactions at all. And that's totally fine. That's not bad. So when to use and when to avoid. What should be the process? How should you deal with it? And how to make it a perfect result? So obviously, it's not that simple as it sounds. Even though we have covered some basics of transactions and how the things work, etc., as some of our experts say, there is no way to see for sure if your system needs distributed transactions by only taking at a high level about your business domain, just because the answer is driven by 2 different stories. There is no single answer. There are always 2 different aspects. First, you need to pay attention at your system feature requirements and your system constraints. Second, the existing or future system architecture. What is it about? How does it work? And why does it work in that way? And only a detailed discovery phase here of these 2 components will lead to a yes or no answer. Otherwise, you just cannot do that. So you always have to think about whether you want to use or avoid making a thorough discovery of your current system. And if there is a silver bullet, it's rough. So technically, in this case, you just should avoid distributed transactions. But obviously, this is not what you want to hear from me during this webinar. And I'm not running this webinar in the night of Wednesday just to talk about such an approach. As far as microservices are considered, they should be built so as to solve a certain atomic business feature. That's the most important part. And the more loosely coupled microservices are, the less is the need for distributed transactions. So if you decided that you don't want to have that and you don't want to risk your business, make sure that your microservices are provided in the correct way and that you have chosen you have chosen to throw out 1 out of 3 in the correct way. Make sure that you are on the right track here and that you have the professional development team who can guide you on what to do in this case. So technically, there is a pretty simple, I would say, way to help you figure out if your solution can do without the distributed transactions, whether you can get rid of those or not. So you have to try to answer 4 different questions. I'm going to be providing these questions one by one and trying to explain them. Why do you need to ask them? So first of all, does the project have microservices or other kinds of distributed architecture at all? Does your project compliant with that? Because maybe if not, well, you should start with implementing such an architecture. Don't use monolith. Don't live on a monolith architecture. That's dangerous for a scaling business. Second one, are there any type or any business flows where a single functional feature is processed partially on multiple resources within a system? Technically, do you have a multi-threading for a single feature? Is it reliable, and do you really need to separate this feature into several subparts? Is it really something you need to have or not? Next one, is this feature mission critical? So if the answer to your previous question was yes, is this feature mission really critical? Does the transaction really need to be treated as a single unit, atomically, guaranteeing a system doesn't have a partial state in case of failures and is strongly consistent. If you're providing software for the AVMs, of course you do. You need, and there is no doubt that you have to provide it in the right way. Otherwise, you should just keep in mind the CAP theorem and just make sure that your business consistency is followed by the specified approach and you're not just following the trend as you want. Finally, the last 4 questions you need to ask. Are there any options to update the system's architecture to shake the pieces of the systems and to box executors of this feature into a single unit? Can you stack this all into one place? Is it possible to do so? If yes, well, technically you can get rid of distributed transactions. If not, well, okay, this is something you have to stick for, and then you have to be more thorough on understanding your system architecture. Let's move forward. So anyway, if you have answered all these questions and you have found an answer to your question and you trying to choose the best way to handle distributed transactions, just again, before we move forward, you should always measure these 2 things according to the criteria. You should think whether you're going to use or you're going to avoid this transaction type. And again, talking about the best way to handle distributed transactions. If there is still no way to avoid such type of transactions and you still want those, or you just cannot make anything to get rid of that, you should do the following. First of all, you need to select a proper architectural approach to manage distributed transactions in your system. There are several different approaches. I'm not going to be stopping at every single one of those because this webinar is mostly an overview of different variants, but you should maybe take a screenshot of this slide and read about it separately. There are technically 4 popular approaches, which are Saga, 2PC or XA, TCC, and local messaging. So you need to choose the proper approach to manage these transactions in your specific system. There are a bunch of different dependencies, such as the security, whether you want to save some costs on the server side, whether you're not, whether you maybe have the support, such as the SysOps or the DevOps, etc. If you have all of those, don't worry, you're good, you can keep working, everything's fine, and that's right. Otherwise, please consider working with it. Next one. You need to evaluate the complexity and the cost of implementation and support. Technically, this proceeds with the previous thing I have talked about. The expenses might be higher than the ones associated with missing ACID properties on some of your product features. So you need to take a look at the complexity, you need to take a look at the cost of implementation, and you need to take a look at cost of support. Those are 3 things that you need to try to measure all together and to find the final unique criteria to identify your best approach. As soon as you do that, you'll be all good and you'll be able to work with it. And the next one, my favorite. Remember the KISS principle. Keep it simple and stupid. This is the best variant. And unless it's not an option, just stick to this approach. Whatever complexity of your project is, your transactions always have to follow the KISS principle, because this is how you make your system work in a simple way. Talking about the crypto, the principle is as simple as never before. Talking about any blockchain related aspects, this is as simple as never before. So this is how the thing works completely, and this is how to do it. Anyway, don't forget that your technology stack is the limit for how far you can go with simplifying. There is obviously might seem that the eternity is not the end, but also always there is some sort of the border, and there is no single solution. Here's an example that we have, and we've been experiencing that some time ago. But anyway, here's just a simple example, how to minimize the use of distributed transactions in a particular system. So let's say that we have an initial design of the system, and it is based on the domain object granularity. So we have some specified object, it is granular one, and at the same time, the execution of your product feature requires the management of multiple domain objects, like 1, 2, 3, several of them together. And at the same time, you are just taking those and you are combining them into the single unit. In fact, you may reach an easier implementation when designing your services on functional feature granularity instead of domain object. So this would completely get rid of mandatory implementation of distributed transactions. And this is just a simple example. So you take a look at the initial design of the system, you take a look that it is based on the domain object approach. Then you understand that all these multiple domain objects can be taken into a single unit, and you transform that into this way. After that, you just get rid of distributed transactions. You get a solid single transaction that's going to be completely following the ACID principle. This is a pretty simple example. Of course, that's an abstract one, but it all depends on your type of business. Let's move forward. What patterns can help and how then can help you? We have already mentioned that architectural approaches that can do the trick to manage distributed transactions. And in this case, I'm just gonna come back to the previous slide and gotta talk about this one. So I'll be just shooting them off. 2PC, otherwise it's called the two-phase commit. Other one is try, commit, and cancel, which is a little bit more complicated version of the previous one. Local messaging and the Saga pattern. So again, I am coming back to this slide to remind you that those are 4 approaches you have to take a look at, and you have to choose one of those to make sure it corresponds to your business. I'm going to try to simplify this for you. So we will go through every single one of those domains and we will talk about them. Let's start with the two-phase commit. So technically, it is a protocol that uses a specified specification, sorry for the tautology, to provide the ACID properties to global transaction processing. Technically, any GTA-compliant application server, such as the GBoss or maybe Glassfish, supports this standard out of the box. So you don't even need to set up anything. You just have the standard working as is. Some applicants may use the REST AT standard to ensure atomicity of transactions. So this is technically an additional standard you're putting over it, and you have an ability to work with it in a completely simple way. A well-known pattern in database systems, 2PC, can also be used in microservices to successfully implement distributed transactions. So it can work as for you as and against you as well. And in the two-phase commit, there is a controlling node. Technically, it houses most of the logic and participating nodes, which act as the microservices on which the actions are performed. And this is why it's called like a two-phase commit, because it has 2 different parts. At the prepare phase, the controlling node technically asks all of the participant nodes, all of the microservices, if they are ready to commit. Otherwise, it will take them into the preparing level. When even single node responds with no, the process will repeat once again, and we'll come back to the prepare phase until all the microservice nodes will respond to yes, they are ready to commit, they are good to go. As soon as we go into the commit phase, when all the nodes reply yes, the controlling node asks them to commit and to start their microtransactions. Technically, this approach has several following drawbacks. If one microservice becomes unavailable in the commit phase, there is no mechanism to roll back the other transaction. So that's a pretty serious problem, because technically there is no rollback for your whole transaction. You just have to start over. Other services must wait until the slowest services finishes the confirmation. And usually there is some sort of the bottleneck appearing at a specific amount of user capacity. So when you reach your user capacity, you will get 1 or 2 or 3 microservices that will be the slowest to respond, and you will get problem with that. The typical implementations of a coordinator are synchronous in nature, which can lead to some sort of reduced throughput in the future. Again, that's about your future capacity. In the beginning, you might feel all right, etc. But when you'll start growing your user amount, for example, you'll feel that as a serious pain. The low speed can cause some scalability issues as well, particularly in the microservices-based applications. So again, it's all about speed. Yes, it's highly secure. You will make sure that it works perfectly, but the speed is the issue here. So pay attention to it. And technically, this is the main approach that I would pay attention at, because the prepare phase and commit phase and 2PC approach is the easiest one, being honest. And this is something that we would suggest starting with if you are just starting your business. Otherwise, if you have a financial solution or any transaction-based solution that works for a long period of time, and you are just not sure if that's something right or not, And technically, if you are unsure that you can achieve the desired result on your own, well, let's be honest, finding some partner who will provide a tailored solution and support it in the long term becomes the major task. It's now not about choosing the best approach. It's not about choosing the best way of how to work with it. It's about finding somebody who can do that for you, because you don't need to jump into the microtransactions, microservices, and the distributed transaction services on your own. There are always people who can do that for you. And for example, our thorough expertise at Insart in solving some complex tasks, such as building, re-engineering, integrating, migrating microservices, transforms into robust and efficient technology for businesses. We work with the big companies, such as an advisor engine, such as LeadSpace, Epikraken, etc. And we work with nonprofits. And we have a huge experience implementing different components and making sure they work correctly. So maybe it's not worth it trying to figure out how the things work on themselves, but just trust it to professionals. Just as I've said, we're always happy to help. Feel free to go to insart.com and leave a contact us note so we can provide you at least a consultation on what we can do. It's completely free and we're happy to help with that. Otherwise, I'm really grateful for you joining this webinar today. I hope this information was helpful, at least as the thorough overall overview of what's going on in the transaction world and why do you need to know about this. And I hope that you will be able to reuse this knowledge to make your business even stronger and generate you a perfect revenue, as perfect as possible. My name is Bogdan. I'm marketing wizard of Insart, and I hope that you will join us for our collaboration. Thanks again for your time, and I'll see you at the next webinars. Bye.